Hello, welcome back to Mrs. Thompson's classroom. Today we're going to be talking about trigonometric ratios. And so we're going to need to define those, and then we're going to calculate them with respect to each other and talk about their cofunction identities. And so let's get started just by defining the 6 ratios. So the first thing we're going to do is we're going to draw a little picture. All 6 of these ratios are defined within a right triangle. And so we're going to choose one angle. Now within a right triangle, we have a hypotenuse, which is always the longest side of the 3, and it is the one across from the right angle. And then we have 2 legs that we're going to call the opposite and the adjacent in respect to their position from angle X. Okay? Now the sine of angle X is defined as opposite over hypotenuse. Okay, now notice I have this X on it. We would read this sine of X. Sine and cosine, tangent, all 6 of these must have an angle attached to them. They are functions of something, so they have to have an input. Okay, cosine of X is defined as the adjacent over the hypotenuse. Okay, tangent is actually sine over cosine. Now that makes it opposite over adjacent. So you can define it either way. Okay, cosecant, which we would abbreviate CSC, is actually 1 over sine. So it becomes hypotenuse over opposite, because 1 over something, that means we're going to find the reciprocal of it. We're going to flip it over. Secant is based on cosine. And so it is hypotenuse over adjacent. And cotangent is actually 1 over tangent, which makes it cosine over sine, which makes it adjacent over opposite. So we have 3 different ways we can talk about cotangent. Okay, now let's use these 6 ratios. Now one thing just to remember, there's a little abbreviation that may help some of you remember the order of these things. You'll hear it said SOHCAHTOA. That's for sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. So that'll help you keep them. If you like mnemonic devices, maybe that helps. All right, so let's calculate some of these. So we have a right triangle. Angle C is 90 degrees. Okay. All right. Now, I do not need to know what the angles are in order to find all the trig ratios. So we're going to find the trig ratios of angle A. Okay. So the first thing we need to do is figure out what C is. Well, because it's in a right triangle, we know the Pythagorean theorem holds true. So I have 6 squared plus 8 squared equals C squared. So that means C is going to be 10. Okay, so now let's just start. So sine of angle A is going to be opposite over hypotenuse. So that gets us 6 over 10, which reduces to 3/5. Now this tells me that the cosecant of A is going to be 5/3 because those two are reciprocals of each other. Okay, then I can find the cosine of A, which is going to be the adjacent side, which is 8, over the hypotenuse, and then that reduces to 4/5. That tells me that the secant of A is going to be 5/4. Tangent is opposite over adjacent, so that's 6/8, which reduces to 3/4. And that tells me the cotangent is going to be 4/3. So if you can find the first three, sine, cosine, tangent, then you know all of their reciprocals. Okay, so now here's another example. We don't have a triangle. They're just telling us that cosine is 5/12. Well, that means 5/12 is the ratio of my adjacent over my hypotenuse. So I could draw a little triangle. Here's my angle X. This would be adjacent, and this would be hypotenuse. So my opposite side, the opposite squared plus 5 squared will equal 12 squared. So that means the opposite squared is going to be 144 minus 25. Okay, so that means my opposite side is going to be the square root of, let's do this subtraction. That's going to be, oh goodness, 119. So now I can find sine as my opposite over hypotenuse. That gives me cosecant. Okay, I know cosine. They gave me that. That will allow me to find secant as its reciprocal. Oh my goodness, I did not flip this over. Okay. And then tangent is going to be opposite over adjacent. And that makes cotangent. Okay, so sorry about that error there. Cosecant is going to be my hypotenuse on top of my opposite. Okay. All right. Now, inside a 45-degree triangle, if I have a 45-degree angle, that means the other angle is also 45 because they have to add to 180 degrees. Okay, that means the two legs are the same. They are actually isosceles triangles. So let's just call them for the moment 1. Okay, now that's going to mean the hypotenuse is 1 squared plus 1 squared equals my hypotenuse squared. So the hypotenuse is going to be the square root of 2. In geometry class, you may have seen the rule written like this. Okay, so we're going to just assume for the moment that x is 1. And let's see if we can figure out the cosine, the sine, and the tangent of 45 degrees. So we're going to let my angle be 45. And we're going to plug these in. So the opposite and the adjacent are both 1. So I'll have 1 over the square root of 2. Now if we rationalize that, we get square root of 2 over 2. Sine is actually going to be the same. Again, the opposite and the adjacent are both 1. So I get square root of 2 over 2. Now if sine and cosine are the same, remember, tangent is sine over cosine, right? So if we take sine of 45 and we put it over cosine of 45, we'll get square root of 2 over 2 divided by the square root of 2 over 2, which equals 1. So this is a special angle that we want to memorize. Now, of course, knowing those 3, we can find the reciprocals and find the other 6 when we need them. So we're going to memorize these 3 values. We can do the same thing for 30 and 60 degrees. So from geometry class, if I make a right triangle with 30 degrees and a 60 degrees, okay, first of all, we know the hypotenuse is the longest side, okay? And we know that the 60 degrees is going to be the next longest and the 30 is the shortest, okay? So actually the way it works is if we let the angle across from the 30 degree equal x, the hypotenuse is actually going to end up being twice that. And the one across from the 60 is going to be the square root of 3 times that. So this is our rule from geometry class. So again, let's let the x's be 1. And see if we can do our ratios for 30 degrees. Okay, so if I'm doing sine of 30, this is my opposite, and this is my adjacent. So the sine of 30 is going to be opposite over hypotenuse. Cosine of 30 is adjacent over hypotenuse. And tangent is opposite over adjacent. So we'll rationalize that one. And we get square root of 3 over 3. Okay, now we can do these same things for 60 degrees. So let's take, and we're gonna, if we're doing the 60 degree angle, we're gonna rename these now. For the 60 degree angle, this is now the adjacent, and this is now the opposite. So sine is now square root of 3 over 2. Cosine is now 1 over 2. And tangent is now going to be square root of 3 over 1. So we notice that these switch places, right? Sine and cosine switch places. The 1/2 is for sine at 30 degrees, but it's for cosine at 60. And the tangent and the tangents are going to be reciprocals of each other. And the reason for this is because 30 and 60 degrees are complementary angles. Okay, now when angles are complementary, we have what is known as our cofunction identities. So if this is a 90 degree angle, we're going to call this x and this y. Okay, so this is going to be little x and little y. I'll make sure. So normally, just for so you know, we normally call our angles capital letters, and the sides adjacent from them are lowercase. Okay, so in any right triangle, the x and y, those two angles are complementary. Okay, x plus y has to equal 90 degrees, right? So if I do the sine of x, I'm going to put x over hypotenuse. But if I do cosine of y, I'll also get x over hypotenuse. So what this leads us to is our cofunction identity, and the fact that sine of x will equal the cosine of 90 minus x. Okay. All right, so if the cosine of x is 5/3, the sine of 90 minus x is also 5/3. Okay. Now what about cosine of 52 and the sine of 38? Well, 52 plus 38 equals 90 degrees, so these two angles are complementary. So the sine of 38 would be 0.6157. So I don't need a calculator. I don't have to draw the picture. I don't have to figure anything out. I just know that if they're complementary angles, then the sine and the cosine will be equal to each other. Okay? All right. So hopefully that all makes sense. Next time we're going to kind of put together our unit circle and put all those special angles, the 30, the 45, and the 60, all around the unit circle so we can start memorizing these things. It's going to be real important to us that we memorize our special angles so that we can do some fun stuff with our tricks. So we will see you next time. Thanks for joining me.